Dear students, good afternoon. Last class we discussed about modulators, right? Modulators. So these are all available in the second chapter of your folio, right? And what is a modulator? Modulator simply changes the parameter of the light signal, right? So what are the parameters of the light signal? Maybe directionality, coherence, phase, isn't it? Frequency, like this. So all these characteristics are all parameters are to be varied with the help of a modulator, right? And today we will see one important concept which will be very useful for our industrial instrumentation side or any process side, right? So in any industry, there should be some importance to measure the parameters like displacements, velocities, sometimes unknown currents, unknown voltages, and sometimes unknown pressures. So these are all the parameters we want to measure it. So, but the question is, how do you measure all these the parameters available in the industries? So, as we are know that we are all across the third year of BTech, right? So in the first semester we have II1 and second semester we have II2. So we all know that all the concepts, what are the methods available and what are the instruments available for measuring the unknown parameters like uh, velocities, pressure, force, displacements like this, right? But the importance of these fiber optics and laser instrumentation is with this available fiber or with this available source like laser, how you are going to measure the same parameters. That is the main importance in this today concepts, right? So if everybody knows that how we are going to make a optical link, how do you how do you establish a optical link? Any optical link can be established with available source, sources available in the transmitter side and detectors in the receiver side. In between there is a medium like waveguide is optical fiber, that is known. Right. So what is there in the transmitter side? In the transmitter we have light sources. Light sources means you can place the LED or maybe laser. So generally, so these applications for measuring these unknown parameters is based on the laser, not by the LED source. So you have to recall once again the laser characteristics. So if you understood the laser characteristics, it is very simple to understand the way to measure with this all these parameters like velocities, displacements, pressure, unknown currents, voltages, maybe liquid levels also, right? And today we'll see. And moreover, what do you mean by a light? What do you mean by light? So everybody knows that light is nothing but electromagnetic wave, electromagnetic wave, and see that the light may be emitted in all the directions. If you place any light somewhere at any one point, it emits the light in all the directions. But actually, for measuring the unknown parameters, we want to we want to take a single light from a single light of a direction of some phase, so from the available light, right? So how it is possible? From the available source of light we want to take a single beam of light, that is called how it is possible means it is possible with the help of a polarizer. You take a polarizer, it will convert the number of emitted lights into a single beam of light, polarizer light. So actually, if you strictly speaking, as per the characteristics of the laser, if you take a laser having this characteristics, this type of characteristics. So the laser simply emits the polarized light. Generally, it emits the polarized single direction light. So with this light, we want to measure the industrial unknown parameters, right? This time we'll see uh, how do you measure um, a, a, a distance or displacement with this uh, with this laser or maybe with this optical fiber. So I am writing a paper here. See that I observe. Is it visible or not? Yeah. See this. The basic displacement measurement. Displacement measurement is done with the help of a sensor or transducer. So how it is possible? The basic principle is like this. So you recall once again how you are going to establish any optical link. So optical link can be established. In the left side you can place a source, right side you can place a detector, in between you place the medium, right? So in this what happens, for measuring the displacements you have to consider two optical fibers and fiber 1 and fiber 2, and in between you can place any one target. So the target nothing but a mobile target. What happens if any light will fall on this a target, right? What happens, the light may be reflected back, that is passing through the second fiber, and you can place one detector. The detector will detect and detects the light intensities. So in the fiber 1 we have a light, fiber 2 also we have a light, but the light intensities are different. The reason behind is we are placing a target, isn't it? When the from fiber 1 if a light is emitted, that has some intensity, when it is fall on the target, right, that is reflected back. When the light falls on the target, that is reflected back, that is measured with the detector through optical fiber 2, right? So the intensity is modified. So how much intensity is modified is proportional to the medium which is moving as a target. So based upon this principle we can easily measure the unknown displacements, right? And see, this is the diagram for measuring distance. Sometimes you can also measure the distance. Displacements and distance comes under the same category. But see, the distance. How do you measure the distance with this arrangement? So what is the arrangement? In this arrangement, there is a coherent light source. Light source means nothing but laser. Is a laser beam, and here we are placing a mirror. It is mirror 1, it is a mirror 2. Two mirrors we are placing, and it is a detector. It is a detector, or uh, you can call it is called a telescope. Is a telescope or fringe counter, right? In this arrangement, how do we measure this, uh, the distance of the unknown? See, in this arrangement, it is in between the source and mirror 1, we are placing a beam splitter, right? So when the light falls on this, the lights are separated into two rays. So one ray is refracted and falls on the mirror 2, and another ray is reflected and falls on the mirror 1. So the upper one is mirror 1, the side one is mirror 2. I'm assuming like this, right? So when the light ray will fall on the splitter from the source, it is divided into two rays. One is reflected, that is fall on the mirror 1. Another one is refracted, that will fall on the mirror 2, right? Then what happens, these two are mirror. Remember, the mirror 2 is fixed, mirror 1 is mobile. Mirror 1 is mobile. See what happens, from the mirror 1, whatever the light is fall on this, that same light is reflected back. And here also, when the light fall on the mirror 2, that light also be reflected back, and these two lights are combined at the point, right? So that we can get fringe, fringe, isn't it? So the point is, how do you get a maximum fringe, or maximum brightness. The point is, how do we get the maximum brightness? Means there is a theory regarding this. What happens if the equal equal in, I mean, difference between the two light paths, path difference of the two rays, if it is even multiples, once again, the difference between two optical path difference is equals to even multiples of 2 pi by lambda. That means 2n into 2n into pi by lambda, 2n into, I'm sorry, 2n into lambda by 2. So you may get maximum brightness. Maximum brightness. You can get fringes, maximum brightness. Otherwise, if the path length difference, if the path length difference is odd multiples, you may get dark. That is nothing but 2n plus 1 into lambda by 2. If the path length difference is odd multiples, that is nothing but 2n plus 1 into lambda by 2, you may get darkness. Dark. The dark fringes you may expect. So there is a relation you can recall in the engineering physics, right? So what is the relation between the phase difference and path difference? We can write the phase difference delta equals to delta equals to um I mean uh, 2 pi by lambda into path difference. 2 pi by lambda into path difference, isn't it? What is the path difference? So the path difference, the two paths we are observing here, these are path 1 and these are path 2. If the two mirrors are on the same distance, so the difference is 0, you can get brightness of the fringe. If the mirror one is moved, if the mirror one is moved from original position to somewhere towards down or somewhere towards up, what happens? The path difference is modified. When the path difference is modified, phase is modified. So that phase of the light we have to measure with this detector, that is proportional to distance. So like this, you can measure the distance of the unknown with these lasers or optical fibers. And one more, one more, pressure. Yeah, yeah, come to this case. So in this, yeah, measurement of strain. Remember, measurement of strain and measurement of pressure, measurement of force comes under the same category, right? So pressure nothing but force per unit area. Strain is also nothing but del L by L. So you are observing this definition of the strain in the sensors and technology, sensors and transducers. Strain can be defined is a change in the length, local change in the length, del L by L, we can represent as del L by L. So very small changes in the length, or force or pressure, force per unit area. So these are all comes under maybe strain, maybe pressure, maybe force, all comes under the same category. So if you understand this diagram, it is applicable for the three concepts, right? See this diagram, what is there in this diagram? There is a light source and a beam splitter, and as a material which is experienced by the force or pressure or any local strain, the output of the this material is connected to any detector, measuring detector, that is given to the a comparator, right? This was the measuring process. And without measurement, whatever the light is emitted from the light source, that is taken as reference for detecting the by the detector, that output is given to the comparator. Here we want to compare the two outputs, which is one is from measurement, one is from uh, direct source, right? By comparing these two lights, we can estimate how much strain, how much pressure, or how much force is applied for this material, right? Generally, generally, what type of material we want to select here? Generally, piezoelectric crystal, right? And see, when what is a piezoelectric crystal? For any piezoelectric crystal, if I apply any force, I can expect a output voltage. Otherwise, for a same piezoelectric crystal, if you apply any strain, I may expect electrical voltage. Otherwise, take you apply any small pressures, I may expect electrical voltage as output. So the basic property of the piezoelectric crystal is, if I deform the crystal, I may expect electrical signal as output. This is a specialty of the transducer, nothing but piezoelectric crystal, right? So for piezoelectric crystal, what are the what are the crystals are available? What are the crystals available? Quartz crystal, isn't it? Rochelle salts. So this is a special types of natural crystals are available. Of course, you can take man-made crystals for acquiring these properties, no problem. But the point is how this strain or any pressure or any force is going to be measured with this laser source or any optical fibers means like this. So when the light is applied on the beam splitter, that light will fall on the reference detector. That light may be detected and given as output for the comparator of one input. Next, the same light is refracted, then that will fall on the crystal. So when the light will fall on the crystal, and for the crystal, if you apply any force, because of the deformation, the light intensities are modified, the light parameters are modified. So the modified light is measured with the measurement detector. That output is given to second input of the comparator. Now compare the two inputs by the comparator. We can estimate the change in parameters of the light, which is proportional to force or pressure or any local strains. So this diagram will give you three parameters for measuring, unknown parameters for measuring, right? And one more, liquid level. So how do you measure the liquid level? You are all know that different methods are available for measuring the liquid level, right? In the industrial instrumentation, we studied number of methods and number of equipments. But the question is how this liquid level is going to be measured with these optical concepts. So in this liquid level, you take a container, water container, filling with some water up to some level. That level you want to measure it. What can you do? You take any material above the surface of the water, and through some light source or laser source, you apply a light through some crystal, that will fall on the that will touch the surface of the water. If the light doesn't touch the water surface, the total light is reflected back to the detector. So there is no change in the light intensities. Suppose if the light is touches the surface of the water, the intensities is modified. The characteristics of the light source are modified. That modified light is measured with the detector, photo detector. So that is proportional to water level available in the container, liquid level available in the container. So in this way, you can measure the unknown liquid levels of a container with these optical methods or fibers, right? So these are this time these are enough. Tomorrow you will see the remaining topics available in the chapter 2. If you have any doubts, you can raise any doubts, right?